Hi, I'm Larry Johnson. I'm a professor at Texas A&M University, and today we're going to talk about the lymphoidal system.
Lymphoidal system, the thymus function and features with its blood-thymus barrier, and then lymph node function and features with afferent and efferent lymphatics, follicles, high endothelial venules, blood and lymph flow of fluid, and the induction of the immune response.
And so throughout the body we have these immune organs that will facilitate this. We have the spleen, Breyer's patches in the gut, we have bone marrow, we have a thymus, and we have lymph nodes throughout the body, and a main player here is the lymphocyte, but also white blood cells, other white blood cells as well. And many of them start with the thymus. The T lymphocytes come from the thymus. We have a cortex and a medulla in the thymus. And then also from the bone marrow. Bone marrow, a lot of pluripotent cells, produced by a pluripotent cell that's located in there that makes all the different blood cells. So with the thymus, we see it has different lobes, one lobe here, one lobe there, and it has a cortex on the outside and a medulla on the inside. In the medulla, we have these Hassel's corpuscles that is produced in there as characteristic of the thymus. So if we look at the thymus, here's a piece of thymus here. Let's see different lobes. We see a dark area, which is the cortex, and a lighter area, which is a medulla. And here we see the Hassel's corpuscles located in there. There's another one right there in the medulla. Now, in the cortex of the thymus, we have a blood-thymus barrier. We have continuous capillaries that are attached to one another by zonioccludens, and they are sheathed by epithelial reticular cells around each. And that characterizes the blood vessels in the cortex and is responsible for the blood-thymus barrier. Also, there's no afferent lymphatics, so there's no lymphatics bringing fluid into the thymus because it's a primary organ, and it needs to develop these cells without the antigens being present. And in those, we can see the thymocytes, which are these dark cells here. We can see mitotic figures in them as they're proliferating. Also, we see these epithelial reticulum cells. You can see the nucleus of it here, the nucleus there, and the cytoplasm. That we see those cells are nerve cells, and they help prevent blood-borne antigens going into the thymus cortex. And then from there, we see those epithelial cells here and here, and they wound up to make the Hassel's corpuscles that we see in the medulla. So they're located in the medulla, the lighter area of the thymus lobe that you see. So you see there's a blood-thymus barrier in the cortex. Another organ is the lymph node, and here this is a secondary organ, and so it does have afferent lymphatics, fluid draining into it, has an efferent lymphatic fluid coming out, and it has a cortex and a medulla as well. And in the cortex we see these follicles with a germinal center or a lighter region that we see. Also, it has a capsule on the outside, and right around on the inside there is a subcapillary sinus. So fluid comes in here, percolates down through here, and then ultimately goes out the efferent lymphatic. And so here we can see these are afferent lymphatics, that is bringing fluid into the lymph node, and you can see some of them even have valves. They're lined by endothelial cells, and you can see the lymph coming in, and then it comes in through the subcapillary sinus, which is right in through there. This is a follicle and another follicle over there with a germinal center, and this is a cortex and a medulla in that region. And so here we can see the capsule. The capsule, as we can see there, and below there is a subcapillary sinus, and then these are follicles. Here in green, you can see where fluid comes in through the afferents, and then it percolates down through, and then finally goes out the efferent lymphatic, and it comes in through here around the subcapillary sinus that we see right in through there. We can see again the subcapillary sinus. Here's a capsule, and this is the subcapillary space here and there, and afferent lymphatic as we see. So we're talking about this space right in through there is where fluid comes through here and then percolates down. So the capsule, germinal center, and it's in the, here we see predominant B lymphocytes in the follicles themselves, and right here in the marginal zone is where we actually find this is actually the parafollicular region, I should say. This is where we see the T lymphocytes. So the B lymphocytes is in the follicle. T lymphocytes is in the parafollicular region that is near the follicles. And also this is where we have a high endothelial venules. So you have endothelial cells that look more like cube cells around these venules. So you got the venules with endothelial cells that look more like cubes than flattened, and this is the site of the blood-borne lymphocytes that enter the lymph node. So blood comes in through here, bringing lymphocytes, and they enter the lymph node at that site to interact with the fluid that's coming through to see if they have the one that reacts with the specific antigens that are there. Now, near the follicle is the parafollicular region, and this is where you have these high endothelial venules that you can see. So, as blood comes in through there, then it's right in these high endothelial venules, site of lymphocyte entry into the node, and it is a one-way street, namely that lymphocytes can come out, but they cannot go in there. The way they leave the lymph node is through the efferent lymphatic. That we see here. So they enter through the bloodstream and then come out through the lymphatic. So a typical endothelial cell is flat, but here we see they're more cubed or high endothelial venules. So what happened in the node is that lymphocytes come out in this region and they interact with the afferent lymphatic fluid coming in through there, and then they go out back through the thoracic duct, around the heart, back to the bloodstream, and then come around and circulates again. So recirculation is a very, very important part of the surveillance of the lymphocytes throughout the body. And so it goes from one lymph node to another lymph node, and so the lymphocytes that can respond to specific antigens will travel around until they find that antigen so they can make a response. And the response may be to produce antibodies, a plasma cell to produce antibodies, or maybe to a killer cell themselves. And here we see in the lymph node, these are the cords, the medullary cords, and this is the medullary sinus. So this is where the lymph fluid is going through here, and then these are the cords that we see with the capsule on the outside. And then after the fluid is percolated through the cortex and medulla, then it goes out through the efferent lymphatic, and I think that's what this is here, efferent lymphatic. So the efferent lymphatic is taking fluid and lymphocytes out of a lymph node. So they come in through the afferents and go out through the efferent.
So we want to thank the original sources of many images and figures and pictures that were taken from various textbooks, and we have acknowledged that here. Thank you for the original sources. That's the end of the lymphoidal system. The thymus function and features with the blood thymus barrier and the lymph node with its function and features, efferent lymphatics, follicles, high endothelial venules, blood and lymph flow, and the induction of the immune response.